Hi, welcome to another module, which is number 4, and which is the most important module, which is related to Python programming, that is functions. Before we actually begin module 4, just I want you to let you know that the location of us in our intuitive Python for you course territory. Okay, so thus far where we have reached, that's what I would like you to know. So so before we actually kickstart the functions module, I would like to let you know that we climbed up 3 stages in our Python programming ladder. We have done with statements 2, and now we are inching towards the higher levels of Python, that is modules and programming in further sessions. But but for now we will be discussing functions. But before we discuss about the functions, what I wanted to tell you, I want to give a summary of our module 3, that's syntax and statements. So what I wanted to revise is, so whatever we have discussed in that session so far, we can put it in, if we it is in a nutshell. The while loop is a general looping statement, but the for is designed to iterate across items in a sequence. Although the while can imitate the for with counter loops, it takes more code and might run slower. Second, the break statement exits a loop immediately and continue jumps back to the top of the loop. The else clause in a while or for loop will be run once as the loop is exiting. Counter loops can be coded with a while statement that keeps track of the index manually, or with a for loop that uses the range built-in function to generate successive integer offsets. So these are the highlights of our previous module, that's number 3. So now we will jump into our new module 4, which is all about functions. So to begin, in our previous videos you have seen basic procedural statements in Python. If not, just go back to the Intuitive Python for You course playlist in my YouTube channel and watch all those prerequisite videos before starting off with this video. Anyhow, here we will move on to explore a set of additional statements that we can use to create functions of our own. So, in simple terms, a function is a device that groups a set of statements so they can be run more than once in a program. Functions also can compute a result value and let us specify parameters that serve as a function inputs, so which may differ each time the code is run. So coding an operation as a function makes it a generally useful tool which we can use in a variety of contexts. So what is the advantage of using functions? Is it learning another piece of code? Nope, not at all. Fundamentally, functions are the alternative to programming by cutting and pasting rather than having a multiple redundant copies of an operations code. We can factor it into a single function. In so doing, we reduce our future work radically. If the operation must be changed later, we only have one copy to update, not many. I hope you got what is the advantage of using functions. Then we will move into modules and it will have a more benefits. But for now, this is the main advantage. We will, if you want to do some changes in your operation code, we will have only one copy to update, not many. So now we will look into how to code the function. So the Python statements are written with a new statement. The def, unlike the functions in a compiled languages such as C. So here def is executable code and Python functions are written with a new statement using def. And it is legal to nest def statements inside if statements, while loops, and even other defs. Next, when Python reaches and runs a def statement, it generates a new function object and assigns it to the function's name. So the below is the syntax of writing a function. You will have a def keyword, which is absolutely a new statement, and then the name of the function, and then a call expression is nothing but using parenthesis, and then inside that you provide argument 1 and 2 and etc. And as it is a compound statement, it will end with the colon, and below you will have a different number of statements, and finally you have to return a result. You have to provide some response. The function should give some response. For that we will use a return keyword and an expression or a value that you want to show it to your user. So that's how our def works. So now we will explore a new way to write a function other than def. What is that? That is lambda. That is lambda. So functions may also be created with the lambda expression, a feature that allows us to inline function definitions in places where a def statement won't work syntactically. The lambda's general form is the keyword lambda followed by one or more arguments, exactly like the arguments list you enclose in parenthesis in a def header, followed by an expression after a colon. This is an example. So we have a lambda keyword, then after that there are different arguments followed with the different arguments. Then function objects are returned by running lambda expressions work exactly the same as those created and assigned by defs. But there are a few differences that make lambdas useful in specialized roles. And a lambda can appear in places a def is not allowed by Python syntax. Example, inside a list literal or a function calls argument. And final one, lambda's body is a single expression, not a block of statement. This is the syntactical difference between a def, a function that we create using def, and then lambda. That is, the body is a single expression, not a block of statement. It is not a compound statement. So here is our example. So basically f is our reference variable to reference it to a lambda function, and we have arguments x comma y comma z and a colon and our statement. So that is an expression which does the addition of all arguments. So now, and we referenced this whole lambda statement to the f. So now we will use f of, we'll call using f, and we'll input some arguments in it, 2 comma 3 comma 4, we'll get the value. This is how we write a lambda function. And so now we are able to generate function object either using def or lambda. But when we call the function, in order it to show some results, we must add one more component in the body of the function, that is return and yield. So we will first look into return. When a function is called, the caller stops until the function finishes its work and returns control to the caller. Functions that compute a value send it back to the caller with a return statement. The returned value becomes the result of the function call. So it is must and should, if you want to return something, you have to use a return in your function definition. Then we have the second component which actually makes function responsive is yield. What is that? It is yield. So the yield keyword in Python works like a return, with the only difference is that instead of returning a value, it gives back a generator to the caller. And yield is generally used to convert a regular Python function into a generator, and the values from the generator can be read using for loop or list typecasting, or using next method. Okay, so here I have actually given some examples, but we will use Jupyter notebook to code all these things that we have discussed so far. So, but before that, we'll just understand some terminology around the functions. The first one is calls. So my function is the name of the function, and this parenthesis, open and closed parenthesis, will be used to call something. This is called call expression. So inside we have arguments, and we have def. Def is a keyword which is used to define the state, define your function, and then return is to return the result. And global is to convert your local variable into global variable, or local scope into global scope. And non-local scope, this belongs to scope, we will discuss later. Then yield, we have this returns a generator, rather a value, and lambda is another type of making a function, creating a function. So now with this, we'll move on to functions in action. So Python functions are straightforward to use. As we all know, there are two sides to the function picture. Okay, a definition, the def that creates a function, that's one side, and a call, an expression that tells Python to run the function's body. This is another side. Okay, so here is a definition typed interactively that defines a function called my function. That's my function, that's the name of the function, which prints hello from a function. When Python reaches and runs this def, it creates a new function object that packages the function's code and assigns the object to the name my function. That's my underscore function. Next, after the definition or after the def statement has run, you can call the function in your program by adding parenthesis after the function's name. The parenthesis may be optionally contain one or more object arguments to be passed to the names in the function's header. Now, when functions is called with no arguments in it, it returns the results as hello from a function. This is what we coded in the Python. And the next thing is, while defining a function, we need to assign names inside the parenthesis of the function. These are known as parameters or parameters. So a parameter is the variable listed inside the parenthesis in the function definition, whereas an argument is the value. It is a variable. A parameter is a variable. An argument is the value that is sent to the function when it is called. When you define, it is called a parameter. When you call it, it's called an argument. I hope you got the difference between the parameter and that argument. So let us explore more about the arguments here. Information can be passed into functions as arguments by automatically assigning to local variable names. Arguments are specified after the function name inside the parenthesis. You can add as many as arguments you want. Just separate them with a comma. Immutable arguments are effectively passed by value, and mutable arguments are effectively passed by pointer. So here we can see one example. So a diff statement and then function name and f name. F name is our parameter, and here to return something we use a print, and that implicit variable f name, and then we have concatenated some string with it. Then when you call something, what you get is you get some output. Okay, so here the creation and then calling or invoking in a proper programming language, invoking. So that's our argument. Now let us look into the various ways to enter arguments when calling the function or write the parameters when defining the functions. So if you do not know how many arguments that should be passed into your function, just add a asterisk before the parameter name in the function definition. This is known as arbitrary arguments, or arbitrary arguments, that is asterisk args. This is one example you can see in on slide. Now on the other way is keyword arguments. You can also send arguments with the key and value syntax. Key is equals to value, that's a key value. So key is equals to value, that with that syntax. This way the order of the argument basically does not matter. So you can see that you have a child one as a key and then Emil as a value. So these are called keyword arguments. And the third way is arbitrary keyword arguments. Here, while defining function inside the parenthesis, add double asterisk before the parameter in the function definition. This allows you to send as many keyword arguments that you want while calling or invoking the function that you have written using quarks. So this is one of the example we have mentioned in our slide. And final component of a function is return. Return lets a function to return the value when we invoke the function. And this is an example. So now in a nutshell, what we have discussed here, the syntax to create a function and then the way to call a function. Now, so to make a function, what all are required? The first thing is parameter while creating a function, and then while calling a function you require argument. So what types of arguments we have, and then the function will be ended with a return statement or else statement. So we have closed functions in action slide with a return. So in a nutshell, we put everything in one slide. Okay, so now what we'll do, we'll quickly jump into our Jupyter notebook, and we will do some action with the functions. So we'll begin with functions basics, and the first one is definition, defining a function. So a def statement, and the name of the function is my fun, that's my underscore fun, and then parenthesis you and a colon, and what you want to give back to the user, what you want to when you call the function, what you want to return is hello from a function. So this is done. And the second activity to do in function basics is calling or invoking a function. So how will you do that? You have created a function, now it is time to call or invoke a function. For that, it's simply use the name of the function and then parenthesis. So we got hello from a function. Then let's check what is the type of the response we got from the function. Okay, let's check. Because we have used print, and what we got is none type. Just note down this. When we use print to return something, the object type we got is none type object. Okay, so now we will be moving on to parameter versus arguments. Okay, now what is parameters? So parameters basically define a function here. So we have to define a function which does the summation of any two arguments that are being sent. Okay, now here what I have done is define the def statement, and then the name of the function is sum underscore 2. Now x comma y are my parameters. This is called implicit assignment. This is implicit assignment, and x comma y are local variables. Local variables to this function. Now these x comma y here we call them as a parameter. While defining a function, we call them as a parameters, and we are returning a value that's x plus y expression using print. So here we have defined our function. So these x comma y here are known as parameters. Now we will see what are arguments. So now we will invoke the function and calculate the sum of 5 comma 9. Okay, so sum underscore 2 is the function name. Now we have to give arguments to that function so that it can give some result. It will do some computation and it will give some result. So now what arguments will give? 5 is one argument and 9 is another argument. The values that we send into parenthesis when we are calling the function are known as arguments. These are called arguments. So now we got the 14 as a result, and the type of this 14 is a none type object. The result we got from this function is none type. And then after that we will see. Okay, so now we will see, once argument is done, then we'll see return versus print. What is the difference between return versus and print? So return, in spite of just printing the result, we can use a return to get the result. But what is the difference? Same x comma y is implicit assignment and these are the local variables. In spite of using print, I have used return, and we'll see the difference. We'll see the magic. So I have used 8 comma 9 as arguments, and the summation is 17, and let me check the type of it. It is int. So that is the difference. That is the difference. There you get none type object, and here you get an int object. So which can be used as an input to some other function, some other calculation. So that's what makes the difference. So then this is the difference between the return and the print. The print gives none type object which is not useful to use anywhere after the invoking of function, whereas return responds with a proper object type that was coded in. So now we will see the difference between the return versus yield. So return, we have seen it will, for example, square is the function name, and the expression that should be returned is x power 2. Okay, so then when I called square the function name and then 5 argument, I got 25. So I got a value. So okay, what we got here is an int object, a value. And the next thing what we'll do is we'll define a function which brings a square of values. Okay, so define, and the function name is squares, and we have taken an empty list, and then using for loop we will append the x in each iteration, and finally we will return a list. And let's see, so we have used the squares of 9, and then we got a list of 8 numbers or 9 numbers and their squares. So what we got here is the series of values or a list of sequence. Okay, when we used return, that time we got series of values or a list of sequence. So now we will use yield in spite of return, and we'll see what is going to happen. So again we have used the same function name squares, and we use for, and then I, a loop variable, and then in membership operator and a range of n. So in spite of return we use yield keyword or statement, yield statement, and then our I power 2 expression. Let's see what is our result. So I invoked the squares function, and then argument is 8. Let's see, this is my result. It is generator object squares at this hexadecimal memory location. So it is not a sequence of values, or it is not of a list sequence, something that sort. So let's check what is the type of this. It is generator. So if you use a return, you may get a int object, list object, square float object, tuple object, dictionary object. But if you use yield, you get one and only one object, that is generator. Okay, so what we got here is a generator and iterable object, not a value or int or list object. If we want to see what does this consist of, we must iterate through it using an iterator. So now what I have done is, this squares of 8 I am checking exactly like that, and then I have used for loop and to step into the squares of 8 because it is a generator. So this is what it consists of. There is no, the result remains same, but when you use yield we get a generator, and we have to use some iterator to iterate the generator and fetch the values out. So now we'll see different types of arguments. So we'll begin with multiple arguments, the simplest one. So we can put multiple arguments, that's x comma y comma z. So, and you can return, that's a multiple arguments. And then we have positional arguments. For positional arguments and multiple arguments are by and large same, they depends upon the position. So whichever, if name and then second one name and then age. So if you give hello, and it will be taken by name parameter if you give the whatever second in while you are calling, if you give an argument in second position, that will be taken by the age parameter. So that's how positional arguments works. Then we will see keyword arguments. Keyword arguments, that's a quarks. For keyword arguments, it is simple. It's key is equals to value. That sort of pair. And this type of arguments, while passing values in the function call, the values can be passed using keywords. Same thing. So this is a normal way of doing. So as name, age, education. So we can actually call it using like this. When you use keyword argument, in that case position is not an issue, it doesn't matter. Then the default arguments is nothing but see in for when we were discussing about the print, we have said so many times, by default, end the end argument by default will be given with escape sequence, the backward slash n, so that automatically whenever you iterate, whenever you print, it will go into a new line. So similarly we can give our own defaults. So here I have given a name and the default value for that is a guest. So when I call, it doesn't matter. If I call just, if I call with some other argument, I will get that name will be reflected. If I don't use anything, then whatever default I have mentioned, I have given, that default will be returned. See here, guest. That's how the defaults will be helpful. Next, arbitrary arguments or variable length arguments. These are also called as variable length arguments. In variable length arguments, a variable number of arguments from 0 to many can be passed to the function. These can also be termed as arbitrary arguments. So the example is here in front of your eyes. So add is the function name, and then inside the parenthesis I have used asterisk args parameter, so that this parameter asterisk, this makes to include variable length of arguments. It is all up to you to add any arguments. It won't restrict you to put this number of arguments. So, and then I have taken one variable which is 0, then using for loop, and after that I am doing augmented assignment, and I want to return. So now you see, when I invoke that add function, in first case I have used only 4 arguments. Brilliant. In second case I used more arguments. In third case I have used almost 24 arguments. Now I will execute and I'll see what's going to happen. So we got value for everything. The function remains same, but the arguments can be used how many you want. It is all up to you. It is arbitrary. You can use any number of arguments. So that is the benefit of using this arbitrary arguments or variable length arguments. The same concept can be applied to keyword arguments, sir. Keyword arguments also, the quarks. So these are called variable length keyword arguments. So a special form of variable length arguments where arbitrary number of keyword arguments can be passed to the function. So suppose we want to pass some details of a person, we can pass using variable length keyword arguments, obviously. So because details of person, so I have taken the function name as details, and I have used double asterisk and quarks parameter, so that you can add as many number of keyword arguments in your when you're calling your function. So here I have taken a tuple type assignment, that is k comma v, two loop variables, and then in quarks dot items directly we have taken items because it will have key and value pairs. That's the reason. And then we want to print. So this is how we have defined our function, and the function name is detail. Now we will start calling our function. So details is our function name. Then we'll use parenthesis as a call expression. Then inside that we will use keyword arguments. So we can, in first case, I have used three keyword arguments. The first keyword is name, is Shiva, is age 25, and course is computer. And after that, I wanted to call the same function details, and then but this time I want to use five arguments. Let's see. Now this guy's name is Hari, age 32, course IP4Y, education artificial intelligence, location Italy. Let's execute and see whether it works or not, because our normal arbitrary arguments has worked, but keyword arguments, let's see whether it works or not. Let's see. See, it is working. In first function has given name Shiva, age 25, course computer. So we have given only three arguments. It has worked. In when we calling a second function, we gave a five arguments and still it is working. So that's the power of arbitrary keyword arguments or arbitrary arguments. So now we will see the most neglected but most important and most useful keyword, that's a lambda. A lambda. So a lambda function can take any number of arguments but can only have one expression. This should be remembered well. Okay, it can only have one expression. So now x okay, so lambda, so we use it as a function. This is another way of writing. I have told you there are two ways. One is using def and another way is using lambda keyword. So lambda keyword I have used, and these are my arguments. You call it arguments, and then basically these are parameters. I have two parameters, and then this is the expression I want to return. So, and the whole function I want to reference it to a variable, a name, that is x. So now the function name has become x. So now I have to, if I want to invoke or call this, then I have to use the function name x and then parenthesis, and then inside that we have to enter our arguments. We have to send our arguments inside this parenthesis. So I have sent 5 comma 6 two arguments inside that x. Let's see how it works. It has given 11. I'll change the value here. I'll put it and then we'll see, check. 30, brilliantly working. So that's how a lambda function works. But the thing is, only one expression. Only one expression. Here you can have only one. So now type of x we see, this is function. So fantastic. Summarize argument a comma b and c, return the result. So the next example is again lambda keyword, and this time three parameters a b c, and then add all three. And now we will call that function x of 5 comma 6 comma 2, and let's see, we got 30, brilliantly working. So and the type of function, type of x, it remains a function because it doesn't matter whether you use def or lambda. At the end what we get is a function. So it's a function using lambda. So the power of lambda is better shown when you use them as an anonymous function inside another function. So say you have a function definition that takes one argument, and that argument will be multiplied with an unknown number. You see this example. So I have my function. So it takes a parameter, it takes some arbitrary one number inside that. Now I want to multiply the number that we are sending into my function with another number which will be given to lambda. So let's see. You don't, maybe you got confused, but still, just follow me here. It will be clear. So use that function definition to make a function that always doubles the number you send in. Okay. So now what I gave x. Okay, I have my function name. Function name is my function, and I call that function, and I have sent a 2 as an argument, and then I have stored this in x variable. So now, okay, let me execute this. Okay, so what I got is a function main. Now x is function. So now you have a function, but inside that function, what you have is a lambda function. So again, you have to call this function to double the value. I hope you're getting what I'm speaking. Because again, I will take you back to this function definition. So this is my function, and here this is my parameter. But instead, what I have done is, in spite of returning a certain expression, I am returning another function, that is a lambda function. So whenever I call this function, then the value what we get is a function. So then we have to call that function again. Then this the first argument and then second argument will get multiplied, and finally we'll get the result. So this is a nesting a function inside another function, but using a lambda. So here then x of 6. So initially I gave argument 2, now I am giving 6, and both will be multiplied and we get 12. So that is the power of lambda. I hope you're getting to know the power of lambda. So now use the sample function definition to make a function that always triples the number you send in. Same. Here also we are doing the same. So my function, and then a nesting return another function. So here initially you will give an argument 3. So then once you call this function, then my tripler also will become another function. So then you have to call that my tripler function with a 5. So then this 3 times 5 will be multiplied. Then what you get is a final value. So that's how a functions works, and we have discussed functions in depth. So now we are we have come to an end of this functions part in module 4, and then we will move on to the next part of this module 4, that is scopes. And by the time you just practice this again and again, and keep watching my videos and keep spreading about my videos and keep liking it and keep subscribing it, and thank you, and I'll see you again in another video.